The future is just around the corner. In a workshop near Mount Fuji, a curious being has appeared. It's 3.8 meters tall and weighs 4 tons. It is a giant humanoid robot named Kuratas. Kuratas is a contemporary artist's creation. He holed up here for 2 years, building the robot with input from an expert. He calls Kuratas a work of art, but it's a sophisticated piece of machinery. A person seated inside can control the robot, move its limbs, and grab things. The artist says he was inspired by robots in science fiction tales and animation. That vision sustained him as he worked in solitude. They think like we do, move like we do, and even sacrifice themselves for us. Robots can take over when things become dangerous. They can plow through rubble, climb ladders, even make repairs. People are turning to humanoid robots to handle all of these tasks. The nuclear disaster in Japan sparked explosive advances in humanoids at the front line of robotics development. This program explores the future that's fast approaching. We were allowed to film their top-secret robotics laboratory. Japan is a worldwide leader in the development of humanoid robots. ASIMO is the country's crowning achievement. Engineers continue to make improvements. ASIMO's most innovative feature is its advanced intelligence. The robot can think and act on its own without human intervention. That's made possible by sensors that replicate our 5 senses. ASIMO's head contains 8 microphones. It uses them to listen and engage in conversation.
わかりませんでした。
2 cameras work as eyes. They can detect humans and use stored data to identify them.
A facial recognition problem?
I don't think so.
Please cover your face.
ASIMO's artificial intelligence analyzes a vast array of information. That's how it understands people's requests and takes appropriate actions. ASIMO also has a sophisticated sense of touch. Its fingers can make subtle movements, like a person's. Sensors are embedded in the fingertips, too. They can gauge the hardness of an object, like human fingers do. Most robots use a fixed amount of strength to grab things. But ASIMO exerts more power to open a tightly sealed water bottle and less when holding a paper cup. Its artificial intelligence uses information from the fingertip sensors to adjust the grip. The developer's ultimate goal is for ASIMO to be a valuable partner that coexists with humans. The engineers who created Asimo all grew up watching animated shows about robots, such as Astro Boy, Doraemon, and Gundam. They dreamed of someday making their own. Asimo's advanced physical capabilities are revolutionary. The robot can walk and run. It can reach speeds of up to 9 kilometers an hour. For robots, walking is much easier than running. When running, both feet momentarily leave the ground. Balancing in midair is no easy task. Sensors in Asimo's waist measure the robot's angle. It leans slightly to compensate, forward or back, side to side. That's how it stays perfectly balanced in the air. Asimo has been evolving ever since development began in 1986, much like a growing child. But something happened that made researchers realize Asimo's real-world limitations. Tests of this prototype were going smoothly. It can easily climb stairs and jump from a height of nearly a meter. It can negotiate obstacles using its arms and legs. It can already handle more demanding environments than Asimo can. Atlas is loaded with technologies originally designed for military robots. A quadruped robot called Cheetah can race through a battlefield at 50 kilometers an hour. LS-3 is for transport. It can carry heavy supplies for soldiers. The ferocious-looking robot gets its strength from a powerful hydraulic drive system. A hydraulic device can be small, yet quite strong. The black cables convey hydraulic power to the legs. That generates the brute force required for harsh conditions on the battlefield. A web of hydraulic cables covers Atlas's body. They form a muscular suit of armor for clearing debris. Another important technology comes from military robot engineering. This machine's joints have a wide range of motion. They allow for flexibility that humans can't achieve. Atlas's joints are capable of moving in 28 different ways. Atlas can crawl through narrow spaces and withstand sudden shocks. The challenge consists of 8 tasks. Driving a vehicle to approach a disaster site. Walking over rubble. Removing obstacles. Opening doors. Using tools to break down walls. Climbing ladders. Turning valves. And making repairs. A single robot must complete all 8 tasks. The development period is 2 years. DARPA will provide contestants with funding of up to $4 million.